In this lesson, we will cover Unit 7, Section 7.5, using an elimination strategy to solve a system of linear equations. Question 1. Solve the linear system 2x plus y equals 4 and negative x plus y equals negative 2. Using the elimination method, we must get a coefficient of x or a coefficient of y to become the same for both equations. When we do this, we either add or subtract to eliminate the x or the y variable that we choose. So if we look already, we'll notice that the y variable in both of these equations have the same coefficient of 1, so we're just going to leave that the same. We're going to rewrite those two equations. We have to decide if we'll add or subtract those equations. You have to keep in mind that they have to result in 0 once you decide to add or subtract. If we add them, we will get 2y, so we can't do that because that doesn't actually eliminate. That is just going to add the like terms. We have to subtract in order to eliminate those y variables. So 2x subtract negative x is going to give us 3x. 4 subtract a negative 2 is equal to 6. We're going to divide by 3 on both sides, and x equals positive 2. As you can see, the answer is D. But we're going to continue on and solve for the y just to verify our solution. So 2 times 2 plus y equals 4. So you could choose either equation here to substitute the answer of x equals 2. It doesn't matter. 2 times 2 is 4 plus y, which equals a 4. If we take away 4 on both sides, of course, y will indeed equal 0. Question 2. Use elimination strategy to solve this linear system. So of course, what we have to do first, we have to eliminate the fractional coefficients. So in order to do that, we'll multiply the whole equation by the greatest common denominator. And in this case, it will be 4. In the bottom equation, we're going to do the same method, and the greatest common denominator here would be 8. So we're going to change our equations first. So we have 3 times 4 is 12, divided by 4 is 3x. Negative 1 times 4 is negative 4y. And 2 times 4, it'll be 8. You have to make sure you multiply every term of the equation by 4. Doing the same process in the second equation, 1 times 8 is 8. Divided by 8 is going to be equal to x. Well, we don't need that equals there. 1 times 8 is 8. Divided by 4 is 2. So we have 2y. 2 times 8 is 16. So now we have equations. 3x subtract 4y equals 8. So I'm just going to write that over here now so we can actually start off fresh with our two equations that we have rewritten. Then we have x plus 2y equals 16. Now we have to try to get the x variables to be the same or the y variables. I'm going to multiply my second equation by 3 in order to get that x coefficient to be the same term. So we're going to have the top equation to be the same, 3x subtract 4y, which equals 8. And my bottom equation is now going to become 3x plus 6y, which equals to 48. Similar to our previous question, we have to subtract here instead to eliminate our x variable. Negative 4y subtract 6y will be negative 10y. 8 subtract 48 will give us a negative 40. We're going to divide both sides by negative 10. And y will equal positive 4. Now we're going to choose one of these equations. We're going to choose x plus 2y equals 16 to solve for the y variable, or solve for the x variable, sorry. So that's going to be equal to 16. So 2 times 4 is equal to 8. So we have x plus 8, which equals 16. We're going to take away 8 on both sides. And x will equal to 8. Now if we have our solution here, 8 and 4, we substitute that back into either the original equations or the ones that we changed here. You will notice that the left-hand side will equal the right-hand side, and it is a great way to verify your solution. Or you can actually graph these two equations and decide where the point of intersection lies on the graph.